In this video, we'll be going over how to configure 61850 in our SCADA Data Gateway. I will be configuring both a 61850 client to get information from our RTU and a 61850 server to present that information up to a SCADA Master. For the sake of this demonstration, I'll be using DTM as the RTU and the SCADA Master. So I have the server for 61850 here, and the client, which is our SCADA Master, that will be receiving data from our SCADA Data Gateway here. So let's go ahead and get started. I'm going to go back over to our SCADA Data Gateway and create a 61850 client to get data from our RTU. So I can right click here and then do Add IEC 61850 Client. From here, you'll have a little pop-up window that'll help you configure the device. So I'll go ahead and give it a name, 61850 Client, and port 102 since that's what I'll be using to communicate with the RTU. From here, you'll need to give it the model. That's the data that this device will be pulling in. There's three different ways you can do that. Number one, you can do it from discovery. If your RTU or your server supports the capability of discovery, when SDG is started up and the device first connects up to your server, you can go ahead and reach out via discovery. This will allow the device to build up its model at the time of connection. An alternate method would be performing a discovery just one time on the server and then building an SCL file based off of that. Then each time you start up the workspace or build up the SCADA Data Gateway from being restart or something, it'll go ahead and look at the created SCL file in order to base that model off of. Alternatively, if you have the model from the device you're connecting up to, you can just provide that by uploading the ICD file right here. And that'll work for any sort of SCL file. Your SCD file, IID, CID, ICD, any of the supported 61850 files can be uploaded in this way. I'm going to go ahead and use Discovery on this client so I can walk through that process with you. And then when I create the 61850 server as the database to connect up to the SCADA Master, I'll just go ahead and provide the file and show how that process works. After that, you can go down to each of these sections and update any information as needed. For instance, I am running my DTM simulation and my SCADA Data Gateway on the same machine, so I can just use the loopback address. I will be using port 102 since that is the default for 61850. You can also come down and change some local configurations such as the IP address for your client, and then there are some advanced options you can change as well. I'm going to go ahead and click OK, and that will generate my 61850 client. I already know that I'm able to connect, as you can see out here in the output, and I can also see over in DTM that this indicator has now turned green. So I know the devices are connected. Let's go ahead and get some data into our SCADA Data Gateway. There's a few ways that you can do that. You just go to the device we just created and right click. From here, you can add a pulled point set, so you can individually pull specific points. A pulled data set will allow you to pull an entire data set worth of points, or you can enable report or goose control blocks. So let's go ahead and see what type of data sets there are within my RTU. So I can go to that device, bring up its model, and navigate down to the dataset section. We have a statistics, a measuran, and an interlocking data set. And I can open these up and see which values are inside. So for the pulled data set, let's just do interlocking for these three ST vals here. So I'll go to pulled data set. And I have the option of the three different data sets we were just looking at. I'm going to select interlocking, which has the three ST vals, the double bits that we were looking at, and I can just hit OK. From there, it'll go ahead and add a node into our workspace here, and you'll see that interlocking the data set has been added. I'm going to go ahead and get all three of these, so I will go ahead and add all three of those attributes. And then I can close this. Now when I click on the interlocking pulled data set, we'll see all of those values and all of those points out here. So, for instance, if I go to this XSWI3 position, I'll just locate that in DTM, and change the value, we'll see that value go on or true here. So, it is coming in, I think, every 3 seconds is what I had that set to. Let me go double check. It's every 5 seconds. So let's speed that up a little bit. Let's make it every 2 so we don't have to wait so long next time. All right. So now if we come back in here and we make a change, we'll see that state change immediately. Now, that is one way to do it. It's just polling every 2 seconds to get the values for all 3 of these points since they were in the data set. Another way you can get values is to right-click and enable report control blocks. So from here, we're going to be given a similar type of layout. Now, instead of looking at the data sets themselves, we're going to be looking at the report control blocks. We see the statistics and the measuran report control block. And just because we set up the file in a convenient way, this BCRB, buffered report control block, is measuran, and the data set here is the LLN0 measuran data set. So that is corresponding to the data set here. That is our measurements. So it is our data objects of the amps and the volts. So we'll go ahead and grab the measurans and see all of the attributes, the qualities, the times, the magnitudes, and everything inside of this data set. So if I hit OK, it's going to, just like last time, ask which points we want. I'm going to go ahead and say add all of them. They're all checked right now, and close this. So now the report control block has been enabled. This isn't polling every 2 seconds. This is just saying anytime these values change, I want you to go ahead and send me those. So I can look in DTM again, looking at my report control blocks, and sure enough, there's a little green check mark next to the measuran saying that the reports are enabled. So now, if I go down to the data sets associated with the measurements, let's go ahead and go down to A, phase A, magnitude of the C-val. If I come in here and change this to 6,000, and we'll make the quality reserved or something. If I come in here, we'll see that the value has now changed to 6,000, and if I open up the quality here, you'll see that the quality bits have changed to reflect that. So with those values changed, I can go ahead and set everything back to good, maybe set the value again or something, and we'll see those immediately, not waiting for any polling, come across the line. So the way that this can be really helpful is obviously this interlocking is being pulled every 2 seconds. But if I come in here and I do a data change in our simulation on our RTU, so if I edit this guy, I'm changing every single attribute in both the statistics and measuring data sets here, changing them every 1 second, and I'm just going to pick, let's see, this 18, so roughly 9 out of them every 1 second and change them. So if I come here and I do start auto data changes, it's going to go ahead and start cycling these attributes, true, false, intermediate, indeterminate. There is some sinusoidal or ramp function going on the analogs between 20,000 and 30,000. You can even layer noise in there. But if I go back to my gateway now, we can see all of these values actually changing. Now it's only 50% of them per second, so we're just seeing some of them change. So all those values are now being brought into our 61850 client. Now how do we map them into a report control block and a data set on our 61850 server side to report up to our SCADA Master? Well, you can do that by right-clicking here and adding a 61850 server. I think we can just give it 61850 server, and I will do port 103 this time. And the reason I'm doing port 103 this time is because instead of having unique IP addresses like most people will, I'm all using loopback for everything since we're all on the same machine. So I will increment the port here to make sure we can still connect. Like I mentioned, now that I'm creating a server, I'm going to provide the SCL file. So I'll go out here and I'll just choose this breaker.icd file and upload that to our SCADA Data Gateway. Now my gateway knows what the model of the 61850 server should look like. I will go ahead and increment this port number as I mentioned and just say use any IP address. I'm not using Goose, so I'll leave that blank. Theoretically, if I set this all up, it should connect, and sure enough, I've now seen my client go green as well. So now I can go over to the 61850 server here, and you see there's not much data going on. Well, that's because the gateway needs to be told what data should be mapped to the 61850 server model. So like previously, I could come in here and look at the data attributes inside of this pulled data set and just drag and drop that over my server. And it will provide you a similar looking window where you can configure where this is getting mapped to. So sure enough, the source is coming from the xcbr pos.stval. I know that this other model that I'm providing to my SCADA Data Gateway has a similar attribute. So I can come in here and say xcbr. I'm just basically sorting on this name. 1.pos And here is, now that I've filtered them all away, the ST-val. So if I click this, it'll go ahead and update the SDO, that's the server data object or slave data object, and the ST-val, the time, and the quality associated. So if I hit OK, that value will now be mapped over, and now we have access to this point here, this XCBR paused at ST-val. And where is it coming from? It is coming from our client, the XCBR paused at ST-val. So as these values are changing on the client, which is coming from the RTU, it's automatically being mapped over and immediately being mapped to this point as well. You can do the same thing with the measurement values, so I'll just grab this mag F and drag it over. Again, I've set up this model to have similar data sets and layout, so I should just be able to type phase A.C val, let's see, mag F, yep, and hit OK. And now we've mapped over both a double bit and a analog value here. Now, just like our RTU has data sets, report control blocks, and things like that, you can do the exact same thing with our SCADA Data Gateway. So those data sets are defined in the model I provided to the gateway. So now if I come here back to DTM, but this time not worrying about the RTU and more interested in what we were considering being the SCADA Master here, I can go ahead and show the model of the master, the client, and look inside at what's configured there. So I'll look at the report control blocks. In this one we have our stat and measurement, but we also have a few other data sets in here. So I can go in and do a command and say read individual points just by, coming in here and finding the point and just dragging it in that I want to read. So for instance, let's go to the data set, let's go to measurement, let's pull that in, and then I can execute a read on that value and it'll update it. Or I can go in and do a report control block, and I'll just go ahead and enable all the report control blocks, and I'll do that every time they connect. So if I hit execute here and hit OK, oops, I'll give it a name. Okay. So now that I've done that, you can see all of the report control blocks are now enabled on my SCADA Data Gateway, and you can see that if I go to report control blocks, they're all marked here. And then if I go to the measurement data set, and then go here, I think I mapped over a phase A and a C-val magnitude. We can actually see this value is changing in time with what is changing on our gateway. So the whole loop looks like this. We've got our RTU changing data every second. That data is then being mapped over to our client. That client is reading them either through polling every 2 seconds or an enabled report control block. All of those values are then mapped over to our 61850 server, and that server is then had a few of its report control blocks enabled and is pushing that data up to our SCADA Master. Now, realistically, we would have a real RTU or a real SCADA Master or things like that. But since everything's in a simulated environment, I know what I'm changing and I know what I'm receiving, and I can verify that I've set the SCADA Data Gateway up correctly. After I've set up every point that needs to be mapped, you can then start adding in real devices to make sure that they work with the physical devices and not just the simulated one. Hopefully this video has been helpful for you to set up 61850 within our SCADA Data Gateway. Thank you for your time.